Hi, welcome to the Building Performance Center. My name is Chris Clay and I'm the Senior Technical Trainer here. Today on this video we are going to do a combustion safety test. We're going to use the Washington State Department of Commerce combustion safety form. That's Exhibit 9.4A. And we are also going to use the technical support document that goes along with it as we do our test today. Also, we're going to use a few tools to do the test. We're going to use a 4-gas monitor that's going to monitor ambient CO and the LEL for us while we're testing. We're going to test our gas piping with a combustible gas leak detector. We're going to test our carbon monoxide in our appliances with our combustion analyzer. We will need to set up for some spillage testing, so we will need to measure the pressure in the zone, combustion appliance zone, with a manometer, and we'll be measuring heat rise in furnaces, forced air furnaces, so we'll be using a dial top thermometer for that. Okay, go ahead and print out your combustion form and your technical support document and come along with us on our combustion safety test. Okay, in the next part of our video, I want to clarify what tests we're going to do on which particular appliances. When you, at first glance, this form is pretty confusing, so I wanted to clarify which tests get done on what items, or make an attempt at it. But anyhow, combustion testing is essentially a little bit of testing and a little bit of visual assessments, all right? So our testing does measurements with these tools that I showed you earlier, and our visual assessment is we're just looking at things, and saying, is it safe, all right? So we don't want to start our test until we know it's safe, so we're going to do our visual assessments first. Those visual assessments are looking for flammable items in the combustion appliance zone, like gasoline and spray paint. Maybe it's too close to the appliance, maybe it's too close to the chimney, all right? We'll also look for combustible items such as rags and paper. Maybe they're too close to the appliance. Maybe they're too close to the chimney. We may even look in the attic to make sure that the chimney's not touching any framing, or is there any insulation too close to the chimney that might burn, all right? Now, for the oven, we're going to be making sure that there's nothing stored in the oven before we fire that up. And we also have to look at the range top burners to make sure that they're burning cleanly. And if we're out in the garage and there's a water heater in the garage, we have to confirm whether it's FVIR listed or that it's 18 inches off the ground. All right. So those are sort of our visual assessment piece that are on this form. The test that we're going to do, carbon monoxide testing, we're all familiar with that, but that gets done on all of our appliances, ovens, water heaters, furnaces, maybe a boiler. Worst case spillage testing doesn't get done on all appliances. It only gets done on appliances that have a draft hood or barometric damper. Those are Category 1 appliances, but this is a Category 1 appliance here. It's an 80% efficient furnace. It shares a chimney with a water heater with a draft hood, so this one does get tested for spillage. But when this is a standalone furnace and it's not sharing a chimney, then it would not be tested for spillage. All right, and that's on the form here. You just have to be able to recognize it. But it's also written in Exhibit 9.4B, our technical support document. Now, depressurization testing, of course we depressurize to get for worst case spillage, but we also do just a depressurization test for wood stoves and fireplaces. That's like line 11 on the form. We will be doing combustion efficiency testing with our combustion analyzer. That's just done on furnaces and boilers because we put that in our treat audit. And then we do heat rise, which is another safety test on furnaces, but that's for forced air furnaces only. Okay, as we continue with our combustion safety video, you can see we're out here on the front porch. We're going to start our instruments. Line 1 asks us to start our testing instruments out here because outside is considered the baseline. We're going to go ahead and start our combustion analyzer. We will start our combustible gas leak detector and our 4-gas monitor. And this will monitor ambient CO as well as the lower explosive limit. And before we start any testing indoors, we have to confirm that we're within acceptable limits. They call that the safe environment. That'll be our next part of our test. Okay, I'm walking in from the front porch and I'm going to check with my 4-gas monitor whether we have acceptable limits of ambient CO and acceptable percent LEL, and it looks like I have 0 ambient CO and 0 LEL, so we're good to continue testing. We do have a safe environment. I'm going to clip this to my belt to monitor those 2 things while we're testing. Now, line 2 on the form is about testing the gas piping. You'll need to test all the gas piping in the house. I'm just going to test a small portion of it for the video today. Alright, we're on line 2 of the form. We're going to use our combustible gas leak detector to check this gas line for leaks. As I said earlier, we're only going to check a few joints to show you how to use the device, but you would be responsible for testing all the gas lines in the house. So I'll check a couple joints here. I'll run the head of the detector around each joint, taking about 1 second for an inch of travel. And if I did get an alert on my device, it would start beeping. Probably like that. And then I would use some leak detector fluid and check for bubbles, and I don't see any there, so I think we're okay with that. Even though that alerted, the bubble solution just tells us whether we have a leak or not. Alright, we're on line 3 of our combustion form, where we're going to identify the appliances and we're going to fill out our form for that. It's very important we know what kind of appliance we're working on, because we don't do spillage tests on all appliances. We don't do depressurization tests on all appliances. So it's important to know, again, to identify the appliance. Alright, so here we're going to give, on line 3A, we're going to give each appliance a name. Obviously, we're going to call this one furnace and this one water heater. The location, you know, here today we're in the test house, but you know, often these are in the garage, or they're in a closet, or they're in a crawl space or an attic. All right, so we just want the location, so if a QCI was coming in later, they'd know where to look for that appliance. We're going to give these things estimated efficiencies. Generally, we just give the furnaces and boilers efficiency ratings, because we're going to put that into our computerized energy audit. We also have to determine if they're open or closed, because open combustion appliances are more susceptible to backdrafting, whereas closed combustion appliances aren't. And then whether they share venting, because what we have here is a water heater and a furnace that are sharing venting. If this furnace wasn't sharing the venting, we wouldn't do a spillage test on it. But since it is sharing the venting with this furnace, we are going to do a spillage test on it. So it's very important that we understand the difference. All right. So we'll go ahead. We're going to call this the furnace, this the water heater. The location, we'll call it the test house, but you know, again, it'd be a garage or a closet. The efficiency rating for this furnace, this is a mid-efficiency furnace. It's about, you know, roughly 80%. So we usually go 70, 80, 90% on our efficiencies. You can do the same with boilers. The type of combustion on this water heater is an open combustion water heater. It's got a draft hood. It's a category 1 appliance. This is an open combustion furnace, and it's a category 1 appliance. All right. This is induced draft. and this is natural draft. So the category 1, natural draft, category 1, induced draft. So I'll put those on here. Shared venting is yes. Type of draft for the furnace is induced, and for the water heater is natural, and they're both open combustion. And we've got 80% efficiency for the furnace. Okay, so that's line 3 of our form. Alright, we're here on line 4. We're going to do our visual inspection of the calves for unsafe conditions. On the form it says, is it free of flammable products and combustibles? I put some flammable products and some combustibles here just to make a point. A lot of times in water heater closets or in garages, wherever furnaces and water heaters are, occasionally that becomes a storage area. And we just don't want to have anything close to the water heater or furnace because they could light on fire. This is, a pressurized vapor that's flammable. A thing of gasoline could do it too. Alright, so we're going to have to remove these, let the homeowner know that we removed them. So on my form, if I had found these there, I would say, yes, I found it, yes, I found it. And then in your technical support document, it actually has some guidelines of what you're, what you're required to do. Essentially, remove the combustibles and flammables. Let the homeowner know that you did that. Maybe get their permission to do it. 4C is the water heater in a garage, and is it 18 inches off the floor, or is it FVIR listed? The reason water heaters in the garage are off the floor is because if your car leaks gas or your lawnmower leaks gas, that's the fumes from that can get light off inside the water heater on the pilot light, and it can explode. It can explode out of the water heater. But they made this type of water heater to protect from that. This is called the Flame Vapor Ignition Resistant Water Heater, FVIR. And it would be allowed to be on the floor because it's all blocked off in here and it will resist igniting the vapors. Generally, you will see water heaters 18 inches off the floor in garages, but if it isn't, that's a fail. And then another thing about these water heaters is basically this is a typical water heater now. All new water heaters are built like this. So this is what you're going to start seeing a lot of. All right. Let's see here. And then 4D says, is a combustion appliance vent, does it have appropriate clearance to combustibles? So we definitely have a clearance problem here. We actually have pipe wrap too close to the chimney. These chimneys should be, this is single wall metal. This should have 6 inches minimum to a combustible item. And so we'd have to cut this pipe wrap back. The next thing we do is we look at where this chimney goes through the attic. Check and make sure it's not too close to the framing. This portion of the chimney is B vent. It has a 1-inch minimum clearance to combustibles, so we want to make sure it has clearance to framing up there of more than 1 inch. And then of course we'd also want to check to see how far away any insulation was from the chimney. So that should take care of line 4 on our combustion sheet. Alright, we're continuing on with our combustion video, and we are on line 5. We're going to set up the combustion appliance zone in worst case because to your right here we have 2 open combustion appliances. The water heater has a draft hood, and it's sharing a vent with an 80% efficient furnace that's induced draft. Both of them are going to get tested for spillage because they're hooked to a chimney that has a draft hood. And that's going to be line 7 that we'll be moving on to after we set up in worst case. Let's see, so the house is set up for a baseline test. The exterior of the house is closed, the interior of the house is open, and we have a pressure here of negative 0.1. So I'm going to go ahead and write that down. Negative 0.1. All right, now the next step, line 5B, is to turn on the exhaust equipment. So in this room here, it's our laundry room, we have a dryer and a bath fan, and in that room there we have a kitchen fan. So I'm going to go check the lint filter on the dryer, I'll turn that on, then I'll turn on the bath fan, then I'm going to go to the kitchen and turn on the kitchen fan. I'm set my form down and I'll do that. Alright, check the lint filter. Super clean. Close the dryer up. Turn that on. Turn on the bath fan. And now I'm moving over here to turn on the kitchen fan. And check my manometer here, and we have a pressure of negative 3.2. All right, I'm going to jot that down. That's 5B. The next step is to turn on is to check air handler impact. So that's line 5C. So if it goes more negative, we're going to leave that air handler on. If it goes more positive, back towards 0, we're going to turn it off. So let's go ahead and check the air handler impact. Okay, the air handler's on. And it is roughly negative 7.5. Alright, that's quite a jump from negative 3.2. Now, behind this, we're going to check our doors now. Behind this door is just a supply duct, so my guess is that if I close this, it's going to go up. It's going to go to negative, okay, so roughly negative 7.6. Behind here we have a supply plus some exhaust equipment, so I don't really know what's going to happen when I close this door. Very little change, it's negative 7.6, so we must have a good undercut under that door. Now we can be checking this with a smoke pencil also, but I have a manometer in my hand and the house is small enough I can get that done without the smoke pencil. So now I'm going to check the last door, and again it's negative 7.6, so that door must have a pretty good undercut under it also because it hasn't changed our pressure at all. Alright, so now we're at the worst case pressure for line, let's see, it's negative 7.6. That would be, and so we're going to leave that door closed. That would be 5D. So we're now in the worst case setup, and this is the pressure and the worst case setup we're going to be using when we test the water heater and furnace for spillage on line 7. Okay, we finished up our worst case depressurization and we got it to about negative 7.6, I think. I turned all those fans off for a moment so I could talk about where we go next on the form, and then we'll get back into worst case before we start our CO spillage test. But what we have here is we have a shared venting situation. We got a category 1 water heater with a draft hood and a category 1 80% induced draft furnace, both on the same vent, so they both get tested for spillage. We'll test for spillage for the water heater at the draft hood, and we'll also test for spillage for the furnace at the draft hood of the water heater, okay? And that's line 7. Well, since we're running the furnace here, we'll also get lines number 9 and 12 done, which is heat rise and efficiency, all right? If this water heater was standalone and it didn't have a share chimney, then we'd use line 6. And if this furnace was standalone and it didn't have the water heater hooked to the chimney, we'd be using line 8. But for today, we're going to use line 7. So I'll go ahead and get it set back up in worst case, and we'll move ahead and do our CO and spillage assessment on this furnace and water heater. Alright, I've got the combustion appliance zone back in worst case. We're getting ready to test the water heater. After we test that, we're going to move on to the furnace. So here we go. I've got get my timer going for my spillage. I got 2 minutes to establish draft, so I'm going to go ahead and turn on my water heater. Okay, I have ignition, so I've got 2 minutes to establish draft. Put my timer down here. I can feel and smell the spillage right now coming out of the water heater draft hood. I'll check it with smoke at 2 minutes. I've also set up, I've got thermometers in on my furnace because I'm going to move right on to testing my furnace. So I've got thermometers on my furnace ready to go for heat rise. I've checked the label on my furnace. It's 35 to 65 is what we're looking for on the heat rise. I have my combustion analyzer ready to go so that once I hit the 5-minute mark I can test the CO and the appliance. So we're in about a minute. It's still, I can still smell it. Okay, it's been 2 minutes. I'm going to go ahead and check for spillage with my smoke pencil, and it is still backdrafting. So it fails spillage. Mark that on my form. Fails spillage. Alright, now I'm going to wait 3 more minutes and I'm going to test the CO then. I'm going to set it to CO air free, and I'm going to go down in the vent pipe here, and there's my 5-minute mark. Our CO air free is going up. It's in the 30s. It's in the 40s. If you check on the back of the form, page 2 of the form, it says we can be as high as 200 parts per million CO air free, and it's leveling off right now at about 47 parts per million. Okay, so that's good. It fails spillage and it passes the CO at this point. Now I'm going to set this back down, and I'm going to go ahead and turn on the furnace. I'm leaving the water heater on. Once the burners start, I'll go ahead and start my 5-minute clock. It has 2 minutes to establish draft. The water heater is still on. It's still spilling. Check my ambient CO while this is starting up. Okay, it's still 0. Okay, it's been 2 minutes. We're going to check for spillage up here, and it's still spilling here. And it looks like we're spilling out of the chimney tube. So the furnace fails spillage. Now we'll wait another 3 minutes to get our CO measurement. I'm set up on CO air free. It's been 5 minutes. My ambient CO is still 0. And we're going to go ahead and get a reading on the air efficiency and also the air free CO. Okay, it's up around 100. This is allowed to be 400 parts per million air free according to the standard. It's 145, 150s, 163, 164. Okay, it's kind of leveling off at about 170, 172 it looks like. I'm going to go up and check efficiency. Efficiency is at 87%. 172 on the CO. Jot that down. 87% on the efficiency and 172 for the CO. Take that out of the vent. Now, while it's running, I've got my thermometers over here. Got my supply. And I'll get my return. Okay, it looks like we've got about 40 degree heat rise, and the heat rise here is 35 to 65, so the heat rise is good. But I'll jot that down at 40 on my form. Okay, now we failed on spillage on both these appliances, and we passed on CO. So we've got some actions to take there. And if I look on the back of the form, page 2 of the form, the test results were greatest gas pressurization occurs with the air hammer on, so we need to conduct further analysis for distribution system problems like leaky ducts or other HVAC-induced imbalances. We're on line 10 of the combustion form now, and it's about the natural gas oven and the range top burners. So I'm going to start by looking at my ambient CO, and we've got 0 ambient CO, and the reason I do that is because we've been running a lot of appliances in here. I want to make sure that it's safe to be here. Alright, so now we've got line 10A requires us to do a couple visual assessments. One of them is to look in the oven to make sure that when we run the oven for the test, we don't light anything on fire. So I always check the lower drawer here, the broiler drawer, to make sure there's nothing in there. And the oven itself, yeah, there's nothing in there. So we're safe to fire the oven. The other visual assessment we're going to do is we're going to look at the range top burners. And we want to make sure they have a clean blue flame all the way around the disc there. There's little orifices there. We should have a flame coming out of all of them. So we go ahead and turn one on. It lights off well. And I do have a good clean blue flame all the way around. Now, if I have a yellow flame or some missing flames or it doesn't light at all, then there's an opportunity to do some work there. The yellow flame or missing flame probably means we have a good amount of carbon monoxide production. We're not going to measure it, we're just doing a visual assessment, all right? And you would do it on all the burners, all right? So the next step is I have my combustion analyzer ready to go, and I'm going to turn on the fan, and then we'll turn the oven up to 500, and at 5 minutes we're going to check the CO in the oven. So here we go. Turn the fan on. Turn this to bake. I'm going to go up to 500. And on. And I'm going to set my timer for 5 minutes and hit start. And so I'll wait 5 minutes. And at 5 minutes, I'll make my carbon monoxide measurement. Okay, it looks like we've reached our 5-minute mark. I'm going to go ahead, and my analyzer's been on hold. I'm going to get it started. It is running. It's hard to hear in here. I'm going to put my analyzer in the throat of the oven here, and I'm going to take an as measured measurement. As measured is not air free, so I've got to scroll up on my menu here to get to as measured, and it looks like it's going up. It's going up. Now it's starting to level off. Okay, it looks like it's leveled off at about 270 parts per million. All right, 270, take it out of there. 270 is a fail. We need to be at about 225 parts per million. And so that would be an unacceptable measurement, and we'd have to have someone come address that high level of CO. Go ahead and turn this off. So essentially, that should conclude our combustion test. Thanks for watching the video with us.